figure out the number of rings of pi bonds, we'll use the number of signals and the integration, and then we'll analyze the signals and draw fragments of what we think might be happening, and then we'll try and assemble the fragments into something that makes sense. Okay, so this is the first one. If we look at the integration here, we've got 10 is our lowest number, so we can figure that this is going to be a 1 hydrogen. This is going to be 5 hydrogens. And these are each going to be 2 hydrogens. We want to figure out our nitrogen deficiency index. That's going to be nitrogen deficiency index is equal to 1/2 the number of carbons, and the number of carbons is 9 times 2 plus 2 minus the number of hydrogens, and the number of hydrogens is 10. So this gives us a deficiency index of 5. Whenever your hydrogen deficiency index is greater than 4, you need to be thinking aromatic ring. And that's 4 right there. And again, then I look over here and I see this peak right here. It's just below 7. The hydrogens in a aromatic ring are de-shielded to that extent, and there are 5 of them. So I'm going to guess that we have an aromatic ring, and it's got something out there. These are our 5 hydrogens. Looking at my cheat sheet, I realized that we've got a hydrogen way down here at 10, and that frequently happens when we have an aldehyde. So that's another fragment that I think might be part of this structure. And here we've got 2 hydrogens and 2 hydrogens. These are both triplets. We get triplets like this with 2 hydrogens and 2 hydrogens whenever we have this structure. So we've got hydrogens on the right carbon are splitting the hydrogens on the left carbon, and the hydrogens on the left carbon are splitting the hydrogens on the right carbon. And that's a characteristic structure that we might expect to get. Then we need to see if we could put all these together, and what we're going to get is we'll get our aromatic ring. Not very artistically drawn, but that satisfies all the prerequisites. We've got 9 carbons, 10 hydrogens, and all of our splitting is explained. There it is, more artistically. I knew it was down there. All right, so let's look at a couple more examples. We've got a carbon 8. So our hydrogen deficiency index is going to be 1/2. We've got 2 times 8 plus 2 minus 10. And that gives us a hydrogen deficiency of 4. Okay. Let's look at our integration. We've got a 9.2. If we take 45 and divide by 9.2, we're going to get a 5 hydrogens here, 2 hydrogens here, 2 hydrogens here, and 1 hydrogen here. We've got 5 hydrogens kind of down here low and kind of a mess, and we've got an index of deficiency of 4, so I'm going to draw my aromatic ring with our group here. Here are 5 hydrogens. We've got a triplet here, and there's a triplet here. So these two are splitting each other. We've got that same structure that I showed you on the last one. We've got this. Is the result of these 2 hydrogens and these 2 hydrogens. And they're splitting each other. And then we've got this lone soul down here. Not sure what to do with it, except that it needs to be isolated. And because it's a singlet. And we haven't used our oxygen yet. So is it possible that we have an alcohol? That's kind of what my question is. It's in the range. It could be an alcohol. Alcohols range from like 2 to 5, so that the placement of it isn't real helpful. We can put this together. I think I put an extra group in there. I did. Let me. This is those 2, and then we need our oxygen. There we go. So this one and this one are here and here. This one is here. And then the ring is down here. Okay, let's look at another one. Okay, so here we've got an index of deficiency, a hydrogen deficiency index. We've got 1/2 2 times 7 plus 2 minus 14, and that's going to give us 1 hydrogen deficiency index. So we've got a ring, or we might have a double bond. We need to do our integration. When we do that, we come up with, it's a 1 to 6. But we have 14 hydrogens. So the 1 to 6 ratio is what we calculated by using the integration values, is really 2 hydrogens here and 12 hydrogens in our doublet. So this is a doublet. And this is got 7 peaks. And what we learned about a doublet and 7 peaks is that that indicates that we have a isopropyl group. So what we've got is a hydrogen coming off here, and then So that's what the 6 peaks of the doublet mean. But we've got 2 of them. Must have 2. And they need to be separated from each other. They can't be with each other. And we've got 7 carbons, and this structure here has 1, 2, 3 carbons. There's a carbon in between the 2. It doesn't have any hydrogens bound to it. So let's see what that might look like. What about this structure? That gives us our 2 isopropyl groups. They're separated by this carbonyl carbon in the middle. We've got the right number of hydrogens and the right number of carbons, oxygens.